Hello, my name is Krishna Garkar. I am here to explain about how we implement this IEEE paper. So we search out, then we find an interesting topic that how to measure a diameter of within an image. Why this topic? Because this topic has many applications in medical field, in mechanical industries, and many other industries. So we a very good paper named A New Method of Circle, Center and Radius Detection in Image Processing by Zhang Mingzhu and Kyo Hornrock. We are a group of 3 people, Aman Kumar, myself Krishna Garkar and Navabhita. We are guided by Nutan ma'am. So let's go ahead and see. These are the contents we will be covering in this presentation. Introduction, how circle is detected, that is a concept named of transform. Then we will see how to find a center and radius of circle theoretically. And we will see the objectives and then flowchart and how we implement it on MATLAB. Then we will be checking some results and finally some applications. Let's see some introduction. So measuring objects within an image or frame can be an important capability for many applications where computer vision is required instead of making physical measurements. This application note will cover a basic step-by-step algorithm for isolating a desired object and measuring its diameter. Sometimes we don't know the values to calculate. We have to just look into the image and we have to do some processing and find the values. That is nothing but computer vision, where we analyze some images. Computer vision has many applications in machine learning and AI. We will not go into that. Let's see further how circle detection is made. In order to detect a circular part, we need to detect an edge object, because edges are the points in the edge where there is a sharp change in the color. So for detecting circles, we need to first make the background of the image indifferent, maybe lighter or even darker than the circle, so we can detect that edges. Once that is done, we can easily distinguish the color change in the image. Let's see what is transform. Transform is a feature extraction technique used in image analysis, computer and digital image processing. The purpose of this technique is to find imperfect instances of objects in certain class of shapes. We will be taking the idea from this algorithm and the centers and radius of the detected circle. So we will be using this Hopf transform we got from the paper. So let's see about how the center of and radius of circle we can find theoretically. Let's suppose this is a circle and we assume this is a detected circle. Okay, here we make P1 and P2. It's P1 and P2 and P1 and P3. This one and this one. They bisect both the chord at the point O, which is the center of a circle. We have the coordinates of P1, x1 and y1, for P2, x2 and y2, for P3, x3 and y3. Similarly, we consider another 2 points where P4 and 5, and we give them coordinates x4, y4 and x5, y5. Now these are some formulas to calculate the center and radius of the circle. These are some basic formulas we learned in geometry. The perpendicular bisector of two chords are y11 is equal to k11 x plus b1. This is nothing but a y is equal to x plus c. After some calculations, we get the first coordinate, and yes, r. This is the formula to find the radius. The main objectives are to detect the circles within range and to find the centers of radius of that detected circles. These two are our main objectives. This is a very simple flowchart that we have drawn. We will be importing a color image. This is the main thing. We will need a color image. And then we'll convert into a gray image so that this will be better. After that we will apply mirror filtering. Then we will select a threshold. Then we will be converting into binary image. Then detect the circle's center. And after that we will be detecting a circle radius. This is what we have implemented in MATLAB. Here we import an image. This function is to read the image. Then image name is color chips. This function is to display an image on command window. After that, to determine the radius range for searching circles, we have this line of code. This is the function to get an approximate estimate of radar of various objects. After detecting this, we will be deleting this function because there is no need further. Now we will start to attempt of finding circles. Now this gray image declare a variable to convert this image into gray. This is the function to convert to gray image. And again to a gray image on command window. Let's see how it will show. This is the original image and this we have got after converting into gray image. So this line code is very important. This will detect circles from that gray image and make the edges darker. After this, some circles will be detected, but not more circles will be detected. So we have to increase the detection sensitivity. This code will increase the detection sensitivity by 0.9. After draw the circles on the image. These circles with a function to draw it. This is the same line to increase the sensitivity. After that, we delete this function, these circles. That is, we will delete the previously drawn circles. Then we will display the third figure. Will be like this. auto detected circles, all detected circles in original color image format. These circles are detected. These are centers and the radius of every circle we have got. Here are the applications. The main application we are excited for is medical, where the size of circles are very small and detection of the circle and its parameters are not possible to found by human eyes. This can be very useful detection tool in medical fields. So in mechanical industries, circular shape tools can be prepared and its parameter can check accurately, as all the tools should be right and in proper size. That we know that in mechanical industries, so precision is very main factor. So this tool will help them to check it accurately. Also in some space ages, this is very effective in calculating the size of planets or stars which are not possible without computer vision. So that's the main applications of our topic.